Welcome back to Decode with Sahil. So today we'll solve the problem product of array except self problem. Okay. So this is the fourth problem of the blind 75 list, and this is an exciting problem, I believe, that challenges your understanding of arrays and optimization techniques. So let's solve the problem. So uh, so the problem is that you are given an integer array nums. Return an array answer such that the answer of I is equal to the product of all the elements of nums except nums of I. So what do you mean by this? So suppose we are given this, so let's consider this example. So we are given an integer array nums 1, 2, 3, 4. So what does it mean? So for 1, so for this particular index, find the product of all the array elements, okay, except this particular element. So for 1, what would be the answer? 2 into 3 into 4. So that is 24. So similarly for 2, product of all the array elements except 2. So 1 into 3 into 4. So that will be 12. So I hope you got the idea. Similarly, if you will consider this example, so for minus 1, the product would be 1 into 0 into minus 3 into 3. So anything multiplied by 0 is 0. So eventually this will be 0, this will be 0. And for 0, we'll multiply minus 1, 1, minus 3, 3. Okay. And what are the given constraints? So constraints is that the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Okay. And it is also asked that we need to solve the problem in big of 1 extra space complexity. The output array does not count as extra space for space complexity analysis. Okay. So uh, let's dive right into the problem. So what do you like? What can you think of this problem? Like, how would you approach this problem? So, like, it is also told that division is also not allowed. It should run between big of n time complexity. So, so firstly, as we are talking about from the starting of the series, that we always need to think of a brute force approach. Okay. So what we can do is, like, for each index I, we can calculate the product of all the elements except nums of I, right? This is what is asked. So what we can do is, we can use a nested loop to multiply all the elements except the one in the current index. Okay. And we can store the result in the answer array. Okay. So like, uh, for I equal to 0, okay, we can multiply 2 into 3 into 4. Okay. And similarly we can, so basically we are doing a nested loop. So for 1, we'll do an inner loop where 2, 3 and 4 will come, and then we'll multiply all of those numbers and store it in an answer array. Similarly for 2, we'll do it for all the 3 numbers. So this will provide us the answer, but it will be a n square time complexity due to nested loops, right? So we need to optimize that, obviously, because it is asked in the question as well that we need to run in big of n time complexity, and there is a scope for improvement. Okay. So what we can do is, uh, we can use a technique. So basically not a technique, we could say we could use a combination of prefix product and suffix products. Okay. So what prefix product means and suffix product mean? Prefix product, so suppose if I talk about 2, okay, so prefix product means product of all the elements in the array before 2. Okay. Similarly, suffix product means product of all the elements in the array after 2. Got it? So, so we'll calculate the prefix and suffix product for all the elements in the array, and then we'll multiply the prefix and suffix product at a particular index, and then we'll fill it in the answer array. So that will necessarily give us our answer. Okay. So let's code it. So then we would understand like how this is working. Okay. So moving on to the code. Okay. So I'm gonna store the uh, length of the array as n. Okay. I'll declare a answer array because we need to store the answers, so of size n. Okay. Now here I am calculating prefix products. All right. So for that, uh, I need to fill the answer array, right? So consider this like prefix product of 0 index, like prefix product at 0 index. What would be the prefix product? There are no elements to the left of the first element, right? So it will be 1, right? Okay. Now I'll start from 1 index because we know the prefix of this particular 0 index element, right? So we have already filled it as 1. So now I'll start the loop from I equal to 1 from 1 index. Okay. I less than n, I plus plus. Alright. And the prefix of I. So the answer would be answer of I minus 1. Okay. The old prefix into the old number. Right. I missed the semicolon here. Alright. Oh, there was a typo. Alright. So this way the prefix sum is calculated, right? So answer of I equal to answer of I minus 1. So for index 1, what will be the prefix sum? So it will be 1 into the prefix. So old prefix is also 1. So it will be 1, right? So this way the prefix sum is calculated for all the elements of the array, right? Now similarly, what I'll do, I'll calculate the suffix product as well. Okay. So I'll take a variable suffix product equal to 1. Okay. Because similar case, because there are, so now I'll be coming from right to left instead of left to right. And to calculate the suffix product of the rightmost element, there are no elements to the right of the rightmost element. So its suffix product would be 1, right? So that's why I've taken this variable. Okay. So now I'll do a loop from right to left. So for this, I'll do int I equals to n minus 1. Alright. I greater than equal to 0. I minus minus. And what I'll do is answer of I'll append this into the answer. So answer of, again a typo. I'm so sorry for that. Okay. So answer of I will be equal to, so answer at the last index would be equal to the old prefix sum, right, into the suffix product. So firstly the suffix product is 1 because we have started calculating it from the rightmost index, and then we'll change the suffix product. So now the suffix product would be changed. So this will be multiplied by the current number, right? So then it is updated at every iteration, and again a typo. Okay. Alright, you got it. So now the answer array contains the multiplication of prefix sum and the suffix prefix product and the suffix product. Okay. So now I'll return the answer array. So this should give us the answer. Okay. So I'll run this code. Okay, this is accepted. Okay. All right. So this is working as expected. So now I'll dry run the code for you for a better understanding. Okay. So what is happening here is that for prefix product, okay, we'll take this example only. Okay. So now answer of 0 is 1, right? Now what will be the answer of 1? Answer of 1 means answer array 1 index. Okay. So it will be answer of I minus 1 into nums of I minus 1. What is answer of I minus 1? It is 1. Into nums of I minus 1, it is also 1. So it is 1. Okay. Now answer of 2 means answer at index 2. So it is 1 into 2 because it is the next element is 2. So this way the prefix array is filled. Okay. Now for the suffix array, the suffix product is 1 initially. Now here it is multiplied by current answer array. So answer of 3 from previous prefix array, it was 6. So I can write the answer array, what it would be. So it would be 1 1 2 and 6, right? For prefix sum, for prefix product, right? And so now for the suffix product, so answer of I, we are updating this answer array only. So now we have started from the rightmost index, so we are updating this uh, last index, so it is multiplied by the suffix product, so it will be 6 into 1 6, right? So again, if I put the answer array, okay, so it will be, so if we take it as 1126 only, so for the last element, so it is answer of I into suffix of product, so it is 1, so it will remain 6 only. Okay, now for this index, so it is 2 into, right, in this line if we see, 2 into 4, because in this line suffix product is changed to 4 previously, so this will be updated to 12, right? So similarly this way, whole answer array is filled and we'll get our answer, right? So uh, and this has a time complexity of big O of n, because here we are iterating n times, and similarly here we are iterating n times, so it is big O of n time complexity. And the output array, so return type is integer array. You might be thinking that we took an answer array, so the space complexity should be big O of n, but output array is not counted as an extra space, so space complexity is big O of 1. So uh, I think you got the answer, and feel free to drop in comments if you feel I should include something, and see you in the next video. Please like, subscribe to my channel.